Yep, hello and welcome to my presentation. My name is Laurent Weber. I'm also known as Scapy. And I want to introduce you to the work I did during the last 6 months. But first I have to do some hardware stuff. Okay, so I had no power supply. Okay, here's the layout of this talk. First of all, I will start with a brief introduction about myself, who I am. Then I will go over to the motivation of this talk and this work, why I did it, and why I think it's important. Then I will introduce you to some background knowledge about GSM networks and Scapy, since I think that not everybody might be aware of the background you need to understand this talk. This will be very short and easy to understand. The fourth part will be about the philosophy of the code I wrote, and when you are using some hardware to play with GSM, you have to send a message in different ways than if you would use it to send for a normal network. So I also had to change different things in Scapy to be able to use hardware, which I will also present later on. The last part will be the most interesting part, I think, and it's also the longest part. I will present my test setup, and I will then also show you some demonstration, which hopefully will work, but I made the experience that it's always working in the hotel room, but not in the conference room. Yeah, so maybe today we have more luck. I will start with some very basic things like how to perform a call using the tool I wrote, or the add-on I wrote on top of the tool. And since this is not really security related and I'm more into security, I'll also present some attacks. First of all, I will start with some well-known and well-understood attacks that you can find in the literature. I will simply recreate them and show you that using my tool it's really easy to get them set up, and that helps researchers to focus on attacks and not on how to realize them later on. And in order to underline the importance of the tool, I also will present some novel attacks that have never been done on the GSM network. My tool makes it really easily possible to create a package for those attacks, and we'll also see this. But I have to say, this is still work in progress, and it's very phone dependent. So I will explain that later on. The last part will be about the source code, and I'm not going to say anything about it now, so you will stay till the end, I hope. I think it's worth it. So about the order, yes, I'm doing security now for leisure, I don't know, for very long, so I would call myself an IT security enthusiast. I just finished my master in IT security at the Ruhr-Universität in Bochum. Since I'm from Luxembourg, I also did some things that were related to security in Luxembourg. For example, I was co-founder of the Chaos Computer Club in Luxembourg. And else for my free time, I'm a CTF player in the legendary Flux Fingers CTF team, which some of you might know. Yes, the motivation of this talk. Until now, it was really hard for independent security researchers to dig into the security of GSM networks, even if it's very old technology. The prices were too high for independent people to look at this, and this has changed now some time ago, because due to tools like the USRP, for example, I will present later on, it's now really possible for everybody to play with this network and everything that's related to it. I mean, some USRP costs around 2,000 euro, and then you have a very good one, and you can basically do everything you want. And it's not the only hardware device that allow you to do stuff like this. I mean, there are plenty other, always more to come. I mean, you have nano BTS and femtocells and so on. Yes, as I said, some time ago, this turnover started and the infrastructure become affordable, and due to a very large open source community, there are also open source tools available to operate these infrastructures, and through this allow people like me to do some things that are related to the security of GSM. Another factor for the motivation of this work was that there's simply no other similar tool available, and before I started to do it, I was talking to some persons that are working in the GSM area, and they were all complaining that there's nothing publicly available that does exactly what this tool does. And that's why I decided to have a look at it. Before, I've never done anything with GSM, so you see, in 6 months you can dig into it and have some fun. Yeah, now we come to the background of the stuff you have to know and to understand. It's a very coarse overview now of GSM network. On the left side, the blue boxes are the mobile stations. So this is basically your mobile phone or everything that is capable of speaking your GSM protocol. Those devices are linked to a base transceiver station over the air interface. And behind this, again, it's connected, the base transceiver station is connected over an A-BIS interface to a base station controller. And finally, an A interface is connecting that part to a mobile switching center or visitor or location register. Of course, as I said, it's not a complete overview. It's only to present it in little piece to people that never have seen anything about GSM. But all this is way too much already for this talk. All you have to know is this part of the diagram. So you have to know what the mobile stations are. In our case, it will be this phone here and the one here. And the base transceiver station will be played by my WSRP. In reality, that would be the antenna of an operator. The stuff with the A-BIS interface you can already forget. That's not interesting for what I'm going to present. Now, Scapy, well, I think most of you know it because it's very good known in the IT security circles, and it's a powerful interactive program that allows you to create package and to manipulate them on a field basis. It has been created by Philippe Biondi. I mean, I think it's even 7 years ago or something like this. It allows you to create very good package, correct package in a very fast way. That's related to the philosophy of Scapy, which I also took for my add-on, and I will dig into it later on. It's easy to add new protocols, which makes it possible for people like me to add a protocol that has never been implemented, and through this, there are also a lot of protocols that are supported now. My protocol, the layer 3 of GSM, the specification are 700 pages of it, and it took me 13,000 lines of code. So it was a lot of work, but the complexity of the code was really not that high. And this allows then to debug, even if you don't understand the protocol, you might find errors because it's always the same. So a community might help to get rid of the bugs that maybe are still in my protocol, in my add-on. I hope, of course, that it's bug-free. But Yeah, you know how that is. Yeah, Scapy takes part of the Python interpreter. This allows you to use every structure you know from programming, like loops and like conditions. That makes it really easy to write scripts to react to some incoming packets and do some clever fuzzing or whatever you want to do. You can write scripts. You can also, if you only want to test something, you can also specify it only in the command line and so on. I really like that tool. I use it often in CTFs, but I think in real life it's very useful. Yes, the code now. As I said, I will introduce you to the philosophy of my philosophy of the talk I did and the philosophy of Philippe Biondi in his tool. Well, one of the most important idea of the tool is that you are able to create valid packets where the default values match and are correct in a very fast way. In order to get this, I decided to drop everything that was optional. In GSM, you have to know that there are a lot of packets that are optional, like you have optional information elements and you have optional fields. So the basic package you create when you use my tool, it's the smallest possible packet where all the optional stuff is cut out, and this allows to be very fast. This is not a limitation because it's still possible to create every possible messages. You can simply add the name of your information element underscore presence set to 1 in your function as a function parameter, and if you want to have that information element. Yeah, now I already talked a lot about a tool, and I never said what it's actually able to do. Since I implemented the whole protocol, you are able to create layer 3 messages on a command line, and these messages can be sent from a base transceiver station to a mobile station. This is what I will do here when I'm going to do some demonstration. I'll only send packets from my USRP to the phones. But you could also send messages from your mobile phone to some BTS and do some fuzzing on an operator's network. But I'm not going to do this. This is related to 2 points. The first one would be, I don't want to crash by mistake the network operator's infrastructure here, and for the moment there's no public possibility, open source possibility to do this. But it could be easily reached. You could, for example, use Osmocom BB, which is an open source GSM stack, and change it in a way that you could send your prepared messages to some operator. This network, but as I said, I didn't have the time to implement this. It should be really easy to do. I mean, if you're fit in C, it should take 1 hour. Yes, the scope of this code, which I implemented so far, it's the specification 0408, which basically is whole layer 3 of GSM, but without the services that are on top of it, like you're not able, for example, to send SMS for the moment. I started to implement this because I thought it would be some really nice feature to have, because SMS could be automated in a good way. I started to implement it, but I stopped to focus more on the GSM part. The limitations, well, I have to admit there's basically one limitation, and that's that you are unable to dissect incoming packets for the moment. This means packets that answers you get, you cannot dissect them using Scapy for the moment. I didn't need it. When I was doing my research, I simply piped the results to over GSM tab to Wireshark, and there you have an dissector for the layer 3, so this was good enough for me. During the coding, and I had some beta testers, and I think they started to implement that part. No, I know they started to implement it, but I'm not sure they will release it, even if they said so. But it would be cool if they would also release a dissector, so we could merge it and have the perfect tool. Yeah. So now I come to the part where we want to send a message over the hardware of our choice. Therefore, we need a method to send raw bytes to some hardware tool. Usually, when you use Scapy, you simply send it over the Ethernet, and everything is done. You don't have to bother a lot. Well, for this case, now I had to change something. First of all, I had to find out how all this stuff works. I was new to this WebRP stuff, and I found out the easiest way would be to use some OpenBTS function that opens you an UDP socket, and then you can simply push your raw packet onto that socket. Well, quite easy to implement. My beta tester, he was using some nano BTS with some, so he was using OpenBSC and did some hacks to be able to also inject packets, and he wanted a TCP socket, so I did this in the same time. And the latest part I implemented was the Unix domain socket, since I thought so it's ready if somebody has the idea to implement the feature I was discussing just a minute ago for Osmocom BB, so because they do everything with Unix domain sockets so far. Yeah, all these three types of sockets should allow the most flexibility, and users should be able to share the code without having to do much patching to make it work on different hardware. So I think this is the best way to have a wider reach. So the last part now, the boring stuff is over, and we come to some more interesting part. First of all, how did I test all this, and how was my test setup? I had a Faraday cage. In this, I was running my PC with my Scapy GSM add-on, which is connected over USB to the user P1. And this again is then connected over the interface to my mobile phones. Yeah, the details of my user P1 I have here. I'm only having one daughter board. I have an RFX 900. It's enough for testing, but if you want to run a full network, you should of course have more. You should have two daughter boards. Very important is the clock you have in your sorry, you have in your user P. I was using a clock tamer. The clock cost 400 euros, I think. But it was all the money. Before I had another, and I had only trouble with it. If you have a bad clock or too much clock drift, the phones are not able to register to your base station, and then you can not even start to send package around. So it's very, very important. To send the message from the user P to the mobile station, I was using some feature of OpenBTS, which is called test call. The test call function is very handy. It sets up channel to one mobile phone, and so it deals already with mobility management and radio link stuff. So you only have to concentrate on the part with call control, which also I did in the next part, in the next slide I will show you. But that does not mean that my tool would not allow you to do all the stuff. Since I implemented the whole protocol, you are able to create every possible message of layer 3. So you could also set up the whole radio link stuff by hand if you like so, but it's not really fun. Yeah, as I said at the beginning, I had a lot of trouble with my clock, so I had to find some other ways to to validate the implementation. Therefore, I searched the internet and I found some Wireshark capture, which at the beginnings, and I simply recreated them. And if I had this, at the end, I had the same hex dump, I was happy because I just created a GSM packet, even without sending it. Well, this is the most complex package I found during all my work with this tool and this infrastructure. It's a measurement report message. Basically, you see people that know Scapy should recognize it. The first thing is you create a package and you name it A, and then you set the different fields with their value. In this case, it's very verbose, but as I said, it's the complexest package I found during all my work. Mostly, if you only deal with call control messages, it's like 2 bytes or something like that. It's very short messages. Yeah. So I compared the hex dump of this package with the one of the Wireshark, and it was the same, so I was happy. There was no big implementation error. I recreated, I don't know, 100 packages or something like this by hand just to validate. Yeah, because I could not validate them with real phones, I did it by hand. And I will give you a link where you can have a look at it if you're interested in later on. But all this stuff is pretty boring, so I decided once I had a clock, now we do something which cooler. Let's perform a call. Here again, you have to know there are 2 different types of calls. One is initiated by the mobile station, the other one is initiated by the base transceiver station, so by the network. As I already said, I'm not going to do some calls from the phone to the network, but only the other way around. Even if, again, that's not a limitation, the messages are implemented. If you have the infrastructure, feel free to test them. So, yeah, we are basically now focusing on the second message part of protocol run. Yes, now the detail of the protocol run. You are sending messages back and forth, and you start with some radio link, and the green messages are radio link messages, and then the red one a message that's related to mobility management, and the blue one are the call control messages. So in this case, I will only do the call control messages, because, as I said, the test call function is already taking care of the rest. So if now you want to perform a call and you have set up your phone call with the test call function, you only need to send a setup message and then a connect acknowledge message to finish the protocol run in a nice way. So Scapy would realize this with this way. Send-UM is a method I added to send the raw packages over the UDP sockets, which I presented some slides ago. And you don't even have to set any field, because the default values are matching perfectly, and you don't have to take care of anything. The test call function, when you set it up, you have to give an IMSI, so the hardware knows to which phone it's talking. So you don't in the call control you don't have to specify any more than this stuff. Yes, and now I'll try to demonstrate that. As I already said, it's not always easy. Okay, now left side you have Scapy GSM. Well, that's my add-on. On the right side, top corner, some log files, and the prompt for OpenBTS is now coming. Okay. Now I'll search for the station on my phone and hopefully I'll find it. So in the meantime, I'll create a packet here. As I said, to have some correct protocol one, I need two packages. The first one was an setup mobile originated message. Now, if you want to see what's the content of that package, it's two, well, basically three information elements. The first one is the TI, and then you have a TD, and then the message type. So it's a very short package. There's only 2 bytes. Still starting. And the other package was a connect acknowledge packet. Again, not a very big packet. Okay, now it found the network, so I'm connecting to the network. Okay, great, I'm connected to the network now. Let's try to set up the test call function. Which hopefully working. Yes, it's working. So now I'm going to send the first packet. And now my phone is ringing, as you hear. Now to terminate the correct run, I'm sending the second packet. Now it's normal that it's still running, ringing. And if I send this, it's killing the connection. So yeah. Yeah, thank you. It's impressive what you can do with 4 bytes. Yeah, I think it's the first time this demo really worked, so can be happy. Well, the first time it works in a demonstration because I did way complex things at home, but yeah. Okay, so now let's focus on some different stuff. Classical attacks, as I already explained at the beginning, classical attacks are attacks that are well known and understood, and you can find them in literature. The first one I'm going to present here, it's an IMSI detach indication message that you send. This time you are sending it from the mobile station to the base transceiver station, so I'm only presenting this in theory, since I'm not sending messages to a network, but just to show you how easily this attack now can be realized. The specification of this packet, or this message, it's represented in this table now here. You see all the information elements are mandatory. The lengths are all fixed except for the mobile identity, where you have a size from 2 to 9 bytes. Yes, a graphical representation of this package could look like this. This is now my representation. As you see, the different values are set by default, so you don't have to take care of it. If you create now an IMSI detach indication message, the blue part, the gray part, the red part, and the yellow part are already set. That are default values that are specified in the specification. So you do not have to take care of this. Now, of course, if you want to do some fuzzing or send some broken package, you can, of course, using Scapy, you can change the fields. But as the philosophy of the tool is to have the smallest valid packet, I set the default value in the correct way, so you do not have to take care of it. The only thing you have to take care is mobile identity. You have to set these 9 bytes, 2 to 9 bytes in the correct way. Well, the first one is the length. The first byte it's computed by the tool. So this would now, if you set the full packet, it would look like something like this. You create the package and then you set the values and have the whole package as a hex dump at the end, and you can send it. The result of such an attack would be that the user would not be able anymore to receive any SMS or call. Active calls would get killed, and for the user everything looks normal. He still sees on his phone that he's connected to the network, and he has no indication that stuff that's not working anymore. Well, this is what the literature says. I talked to some persons who said it depends on the phone, on the operator. Sometimes you don't see that you're connected anymore and stuff like this. Now imagine using Scapy, you could send that every second, so you could disconnect whole buildings if you would like to. It's really easy to do stuff like this now. If it's good, it's another question, but we are the good ones, no? So don't do that. Yes, and now second attack. Well, it's I called it attack. Well, it's something I found in the specifications. It's simply an authentication reject message. When you send this one, the user gets disconnected from the network. He has an inscription on his display that says SIM card registration failed, and he's unable to connect to this or to any other GSM network until he's restarting his mobile phone. This also could be very annoying if you pretend to be a real operator and then people log into your cell and then you start to do stuff like this. It could be really annoying. Yeah, I will try to demonstrate this one as well. But first of all, I will show you the details here of the packet I created before. Because this packet has it's the longest package we have seen so far. You could set all these bytes with diagnostic foo. So even if the default packet is very, very short, you could have a packet that has some bytes which related to the information element cores. Just to show you that not every package is only 2 bytes long. Okay, let's try to get a demonstration running again. It's not always easy, as you might know. Therefore, I have to reconnect to my first search again for the base station, and then connect to it again, and then restart the loop and so on. So during the past 6 months, waiting was one of my favorite operations I did. So, yeah. Maybe one should invest some time to fix or to patch the test call function of the OpenBTS to make it a little bit more clever. So this is the package I want to send. It's again only very, very short packet. I'm trying now to make it work. Usually it fails here, man. I do it 2 times, one after the other. No. Okay, well, yeah, basically it's the same, except you send another packet. But I will try later on, but no, I don't think it will work again. As I said, it's very strange sometimes. And so now, last part of this talk, the novel attacks. Novel attacks are attacks that have never been done on the GSM network. The attacks are not really new, but never been done on the GSM network. I decided to do some research on the state machines. There, I focus on the state machines of the mobile subscriber on the mobile station side. Of course, again, that's not a limitation. You could also start to play around with the state machine of your operator or of of OpenBTS and stuff like this. But I only did the mobile subscriber side, and you have so many possibilities that alone if you want to do this side in a clever way and in a good way, it will take you, I think years. The idea behind this novel attack is to test the correct behavior of the implementation by sending correct messages, but in a wrong order. So this would be really easy to do with Scapy, since you could do some programming and the default package you are using are already valid packages. So you could start, for example, by sending the basic package with the smallest packet, and then try to add more information elements and change the order of the packet. So it will, as I said, there are so many possibilities. It would, if you are not reverse engineering the baseband stack on the other side at the same time, some black box testing will take you very, very, very long. Yes, and now for the persons that have never seen a state machine, I think most of you here should know what it is. I did some illustration here. That's a subgraph of the mobile station state machine. You have the states and then one action, and then you get to the next state, and so on. And now the idea would be, for example, if you are in state 1, you send an event, and through that event you try to reach a state that is not the next state, but one that comes at the end or something like this. Yes, as I've said, this is a work in progress, given the complexity, and yeah, you should try it on different phones and so on. It's a lot of work. So I will present now the attack with some call clearing example. Call clearing is when you have done you have finished your call, you disconnect and you release the link and the channel and so on. This is the protocol run, how it is defined in the specifications. And the idea is now, one idea I had, and I think that's why I picked this example, because I tried a lot. I think it's easy to understand what you could reach here. If you now manage to somehow reach a state where instead of releasing the channel, you manage to make the user only think that you hang up, but in reality you are still somewhere you recreated a link and you are eavesdropping or something like this on the conversation. That was the idea I had to illustrate this stuff. For example, you are calling a director of some bank and you are talking to him, and after you are hanging up, but in reality you are still listening what's happening on the other side. So you could gather some information on I don't know, some confidential information without the other knowing. That was one of the idea I tried to reach. Now this is only 2 test cases I did. It was like, first of all, you set up a phone call, but instead of finishing the call like it's specified here with a channel release, you are sending and set up mobile originated. That was the package we used to set up the phone call, for example. So maybe depending on how the implementation is, this could lead to the fact that the phone would set up again the phone call or something like this. Well, at least that was my idea. And the second test was basically the same thing I did, but instead of sending and set up mobile originated, you are sending some connect acknowledge or something like that. So you hope that the phone will reconnect you or recreate a link to the phone. But yeah, these 2 examples didn't work, at least not on my phones. Well, I only had my 2 Nokia phones, which is not very, very clever for testing, since yeah, I guess the state machine is most part will be still the same, even if the phone have 5 years age difference. But I found other things that look very promising, and I'm still looking into it. But it's like always, if you have only these phones here, you cannot do much with it. You should have some developer phones, or you should somehow have the baseband stack to reverse engineer, and then you would, I'm sure, you would find things yeah, in a really easy way, because I'm pretty sure there's plenty of stuff to find. Yeah, so that was basically everything I had to present here. I'll only some words for the source code. Yeah, I was developing this stuff on my own repository, and yeah, I would have preferred it to be in the real Scapy distribution, and so that everybody has it, and maybe this would lead some people to look at GSM even if it wasn't the plan from the beginning. And so I decided to follow Linus Torvalds' idea to put it somewhere where everybody can fetch it and then have a copy of it, a mirror of it. In this case, I talked to Philippe Biondi, and he merged my code into Scapy. You can find my code in the contrib folder, and yeah, feel free to play with it. As I said during the talk, at the beginning, where I didn't have the clock, I created a lot of packets by hand, and if you want to look at this package for to get started, if you have never used Scapy, or if you want to see a little bit how it's working with Scapy GSM, the first link is an example. There you find all these examples I did. And the second link is my thesis. I wrote a master thesis on the subject, and it's the first time I release it, so well, you are the lucky ones, or unlucky, depends. Yeah, and feel free to send me bugs, reports, bugs, feedback, and questions, and bug reports. So this way, to my email address, or follow me on Twitter if you will, if you want. It's fine with me. Yeah, I want to thank you for your attention, and yeah, are there any questions?